By the way, this is not a church service, so those of you in the back, you're welcome to come up. Sit back there.
We're going to respond.
What I'd like to talk about, first of all, is Stu's legacy. And if you talk about Stu and talk about Stu's legacy, I think you have to talk both about Stu the statistician, but also Stu the person. Dick certainly got into that, David as well. I want to tell you my experience with meeting Stu for the first time, which was memorable for me at least, maybe not for anybody else. I want to talk, I can't talk about Stu and his legacy without talking about EWMA, exponentially weighted moving averages, Bayesian methods. And then I'd also like to talk about a couple aspects of Stu's career that have influenced me personally quite a bit, that perhaps haven't gotten as much notoriety or much association with Stu's name as these other topics, those being sampling paradigms, sequential approaches, the integration of subject matter knowledge, and the role of variation in what we do. I don't have one of those fancy gadgets, so I just have to do it the good old-fashioned way. In terms of Stu's legacy and his influence on the profession, there's many dimensions that we could talk about. I'm just going to list a few of these. One is as a leader and advocate, and I would argue this has more to do with Stu the person than Stu the statistician, although, of course, both are involved. Teacher and educator, we just heard about that. A researcher, we heard about that in terms of his technical work and getting the journal Technometrics started. A big role that he's played is that of integrator, bringing different disciplines together, and having been involved in Technometrics myself for a number of years, trying to get two professional organizations to work together and cooperate is nothing short of a miracle itself. I think we also need to talk about Stu in terms of being a builder of the profession. He did a number of things that we perhaps might gloss over that had tremendous influence on developing statistics as a profession. For example, the short courses he did, we talked about short courses he did to provide funding, capital, that enabled journals to start and other things. He helped the Chem division of ASQ quite a bit with these short courses. Obviously, there's a lot of things he could have been doing with this time. He could have been pocketing the money, but these are things that he chose to do because he wanted to build the profession. We heard about his involvement in Technometrics. Stu played a key role in getting the Fall Technical Conference started and the Quality and Productivity Research Conference. So he's done quite a bit over the years to build a number of aspects of the profession, Technometrics being one of them, but certainly not the only one. If we look back over the history of this profession, of this society, ASA, the list of people that have had more influence on the profession, I think, would be a pretty short list. Now, let me talk a little more personally about my own relationship with Stu. As many of you know, my father was a professional statistician and knew Stu before I did. And so Stu has a habit over the years of calling me Art. And as late as, was it March of this year, the conference in the Netherlands, he introduced me to a group as Arthur Hoerl. And people were looking around the audience. And so I'm Roger. See, remember that next time. So I'm showing up for my first board research conference. I've heard all the stories about what happens. I'm there for the first time, just kind of soak all this in. And I won't mention their names, I know who they were, but two statisticians are giving a talk on nonlinear design. It's a very complex situation with multiple sources of variation. Now, in order to derive their mathematical solution, they write down an equation and it has a sigma squared on the end. So Stu raises his hand and said, "Excuse me, there's actually several sources of variation in this problem, and you've got an equation there with a sigma squared at the end. How does that relate to the different sources of variation?" Well, unfortunately, they sort of blew Stu off. And they said, "Well, it's kind of complicated, you wouldn't understand, don't worry about it." Well, those of you that know Stu, he started squirming in the seat, getting a little agitated. He let somebody else ask a question, and then a little more forcefully he said, "No, I really want to know, how does this sigma squared relate to the uncertainty in this model?" And they gave sort of a half-hearted answer, which didn't satisfy Stu. Stu was seated about where Conrad Fung is. Raise your hand, Conrad. He was seated about there. So at this point, Stu proceeded to get out of his chair and march up the aisle. And I'm just sitting there. This is like my first conference I've ever been to. These guys are up on the stage, and here comes Stu Hunter out of the audience, walked right up on the stage. And in those days, they actually had blackboards. So they had a blackboard here with the equations. And I'll never forget Stu coming up to the blackboard and saying, "Let me ask it this way." And he's pretty agitated now. Suppose I were stupid enough to run the same set of conditions twice. How would the variation between those two runs relate to this sigma squared right here? He pounded the board so you could see it shaking. I thought it was going to fall over. Right here. And the whole place got quiet. The two speakers kind of looked at each other like, you. And finally they said, "We can't answer your question." Which I think was the answer Stu wanted to hear because he knew there wasn't an answer to it. But from that point on, if Stu asked me a question, I give him an answer. A-R-T-H-U. And I wouldn't do. I'm not the only person that remembers the first time they met Stu Hunter. A lot of other people remember the first times. Certainly at the Gordon Conference, my expectation as a young statistician is the guys like Stu Hunter, George Fox, et cetera, they're going to sit at a separate table, and I'm going to kind of sit with the lowlifes over here. And I found just the opposite. People like Stu would come up, "Oh, what's your name? What do you do? What do you work on? Oh, what kind of problem?" And they would just start a conversation. So in Stu's mind, there was no such thing as the people in the in crowd and the people in the out crowd. It was strictly a matter of ideas, and if you didn't answer his questions, then you're in trouble. But if you had something articulate to say, you had ideas, he really didn't care who you were, where you came from, et cetera. And that's a unique quality. Okay, you remember this one. So of course, 1959, this is the first volume, not the first issue, but the first volume of Technometrics. This is the famous paper. At that time, it was called Geometric Moving Averages. Stu, of course, realized that a more technically accurate title for this methodology would be exponentially weighted moving averages. And he immediately saw the importance, the potential usefulness of the idea, and he's been promoting it ever since, including now, including this year. You gave Ron Snee and me a lecture about it in the Netherlands. I did take notes. Now, as many of you know, Stu has a long history in Bayesian methods, and what I would like to point out, back in the 80s, which I would say was before Bayesian methods really became in vogue, before they were widely practiced, Stu was out there taking a stand, never bashful about stating his opinion, and in this case, not even talking about Bayesian methods for statisticians, but actually Bayesian methods for engineers, and that we needed to incorporate Bayesian thinking and approaches in the way that we train engineers. This was ICOTS 2, by the way, 1986. There's no, some guy walked through the door. That's not it. Now, for the rest of the time I have, which is how much? Great. Good. Shouldn't have said that. What I'd like to talk about are some important seeds that Stu has sown that have had a big impact on me professionally and significantly impacted the way I think about the application of statistics. One of the fundamental paradigms that we often have in statistics is that we're sampling from the bowl. That I had the courses with the green balls and the red balls in the urn, and if we sampled 5, what's the probability of getting at least 3 green balls and all that kind of stuff. How many of you had that, by the way? Yeah, please tell me I'm not the only one. All right, good. And of course, the message behind that is we live in a static world. Everything stays the same. And I can be sampling over time, but I'll always get the same answer within some degree of statistical uncertainty because life is static. The world is static. Now, Stu has been saying for a long time the world is not static. That it's actually quite dynamic. And if you think about the EWMA, the main reason that I've heard Stu talk about as to why we should be using tools like that is because the underlying assumption is not a static bowl. We're not sampling from something that's going to be constant over time, but rather we are sampling from a dynamic process. And things are likely to change over time. Yet sometimes things look static over time, but that's the exception rather than the rule. And this is emphasized not once, not twice, but I lost track. How many times in Box Hunter and Hunter this specific point is mentioned about the static sampling hypothesis, why that's so dangerous, why we need to plot data over time. And of course, I'm talking about the first edition in the 1970s, where you didn't see a lot of people talking about sampling from the dynamic processes and that things are likely to change over time. Don't assume they're static, assume they're dynamic, and then once in a while you'll be surprised in their static. And I don't have time to get into it, but Stu has a great talk called The Arts of Charts with documentation that gets into this point as well. And I would argue we still haven't really caught up to this point. Stu and his colleagues were talking about this in the 70s, and if we read most of our literature and our books, we still haven't caught up to that. But it impacted me from that point on, and that was always my expectation from that point on, that things are likely to change over time. Another key point is that real applications, successful applications at least, almost always tend to be sequential in that we don't start out with a given problem, with a given set of data, we do the correct analysis, and we're done. Which is, I would say, typical of most end-of-chapter exercises in textbooks. What Stu talked about in Box Hunter and Hunter and elsewhere is that generally we have to be thinking about a sequential approach. That's one of the fundamental justifications for highly fractionated designs. It's not going to be our last design. We're going to use this initially to find the key factors, then we're going to study them a little more seriously with perhaps a factorial design, then we're going to use perhaps a response service second order design, and so on. This was the whole justification for response service designs. I refer to this as a scientific method view of experimental design, where we're thinking of it as a sequential process as opposed to there's a well-defined problem, what's the right design for that particular problem, and then we're done. And of course, evolutionary optimization by definition, by the name of it, is evolutionary in nature. The expectation is we're going to be doing this over time. It's not a one-shot study. I would argue, and I'm stealing this from Xiaoyu Meng, that real problems do not correspond to a recognizable textbook chapter. That is, you tend not to have a regression problem or an SPC problem or design of experiments problem. You tend to have a problem that requires you to use several different methods in a sequential approach. And again, Stu was one of the first people to be making that point. He's made it very consistently over his career. I'm not sure how many people were listening. I listened. It helped me quite a bit in my career. And this, I shouldn't have to say, and probably I'm preaching to the choir with the folks in this room, but certainly if we read the external literature, articles such as The End of Science and so on that are suggesting that with the big data phenomenon, subject matter knowledge is no longer needed. We can always find the answers in the data. If we just get more and more data, we'll solve every problem. That's the paradigm that many people have today. Again, Stu was one of the pioneers in emphasizing the criticality of interplay between subject matter knowledge and data. That we needed both, not one or the other. This is one of my all-time favorite quotes. I've used it repeatedly. Data have no meaning in themselves. They only have meaning within the context of a conceptual model of the phenomenon under study. This is from actually the first edition of Box Hunter and Hunter. And Dick DeVoe and others have pointed out that if you look at the data, popsicle sales are very highly correlated with shark attacks on Long Island. But I would suggest most people would agree if we shut down all the popsicle stands, that's probably not going to solve the shark attack problem. They're very highly correlated. Now, I thought so much of this that Ron Snee and I, when we wrote a book, we stole this blatantly from Box Hunter and Hunter. We did give you credit, Stu. So I made sure when I made the graph that it included this in there. So we definitely gave Stu and his colleagues credit. But we felt very strongly that the issue of needing to start with subject matter theory and have an interplay between data and subject matter theory, and also the sequential nature of studies, is critically important to successful application of statistics. Certainly, if we're teaching engineers, scientists, other people, psychologists, that might actually use statistics, my view, I happen to agree with Stu, this is the way people should be thinking about it, not what's the correct technique that I need to use for a given set of data. Now, that's built into this, so I'm going to get a given set of data. I do need to know the correct way to analyze it. There's nothing wrong with that. That's good. But I need to be thinking about it within a broader context of a sequential approach that integrates data with subject matter knowledge. Not only must the subject matter guide my data collection, but then when I interpret the data, I have to interpret it relative to my original subject matter. We have to learn from it and not just look at the data as if it were the sole answer. Another interesting topic is the whole concept of variation. When I was learning statistics, usually, not always, but usually the standard deviation was a nuisance parameter that you needed to get an estimate of in order to test an average, which is really what you wanted to do. You really didn't care about sigma, you just needed it somewhere in the test. And another quote from Stu, the gods love the noise as much as they love the signal, pointing out that the noise is very important as well. The variation is very important. And of course, Deming talked about variation being the most critical thing. He's often quoted as saying his message, if one had to boil it down, came down to understanding and reducing variation. That's an important point. I would argue that Stu's writings on variation, his commentary on variation, are equally important. And of course, I did a lot of nested designs, components, and variance designs when I was an intern at DuPont. I guess partially because it's a lot of chemical processes. But I haven't seen a lot of books spend time talking about components and variation, why that's important, why it's important to know where the variation is coming from, not just the total amount of variation, but how much is coming from the test method, how much is coming batch to batch, how much is coming from how you do sampling and things like that. I still think it's important. So to summarize, probably everybody in this room has been influenced to some degree by Stu's work. I was never a formal student of Stu's, but I was a student, not formally, but I observed, I read, I paid attention. And he certainly, his writings, as Stu the person, the kind of person he is, have had a significant influence on me in my career. So maybe that's two things you got to take to your grave now. Many of the key points that Ron Snee and I have made in our collaboration, if you dig deep enough, you find Stu Hunter at the bottom. I'm not at all ashamed to say that. And in fact, Ron, unfortunately, had an emergency with a client, had to leave. But I asked him, are you okay with me saying this? And he kind of laughed and said, of course. It's obvious, yes. A lot of the things that we've been talking about and have talked about, if you dig deep enough, go back to things that Stu said originally. So in the work that Ron and I have done on statistical thinking, the whole thought of we're probably sampling from a dynamic process, not from a static population. We're never sampling from a bowl of green or an urn with green balls and red balls and yellow balls. I've never done that, maybe you have. That's never the paradigm we're dealing with. It's always a dynamic process. That goes back to Stu. The importance of variation in its own right, understanding where variation comes from, realizing that some variation can be eliminated, some can't, and some can. And then more recently, of course, Ron and I have talked a lot about a concept called statistical engineering. We've tried to be very clear that we're not claiming we invented any of these concepts. And so I want to reemphasize that. A lot of these go back to Stu's work. The importance of having a context for data. Again, the quote I gave from Stu was 1978. We refer to that as a data pedigree, understanding where the data came from, not just getting a lot of data, putting it in a computer, and hitting the button. The integration of subject matter theory with empiricism, that it's not one or the other, but it's really both. Again, Stu. And perhaps most important, the idea that real applications of statistics almost always involve a sequential approach using several methods over time, as opposed one-shot study that we typically see in textbooks. All these things go back to Stu. So I feel not only did Stu have a significant influence on my own career, but we still have a lot to learn from Stu. You got to get my name right, but we still have a lot to learn from Stu until we get to the point where we say, okay, we've really taken everything